Welcome to the Grand Solar Minimum, folks. Today is July 24th, 2017. Waiting on our guest, Lee Wheelbarger. Lee will be joining us tonight. He is having some internet issues, as that seems to be common for a lot of folks these days.
He's back. I hear him.
Lee, are you there?
Yeah, I'm here.
All right. Thanks for coming on tonight. Such short notice, but we wanted to talk a little bit. Mari put out a lot of videos today about extreme weather from all over the world, really, and it's getting to the point where she can't keep up. We have really seen an uptick here in the last 7 to 14 days of extreme floods. We're experiencing flash flooding up here in Buffalo. 3 times in 7 days? That doesn't happen up here. Maryland had a tornado today. I talked to a guy in the chat 2 days ago. Nova Scotia, Canada, 100 degrees with a tornado warning. I checked the weather yesterday in my hometown, Dayton, Ohio. Their humidity was 100%. The dew point was at 80 degrees, and the temperature was 85, so it felt like 100 degrees outside. Again, that's not it's not normally that muggy in that part of the country as well. So, any ideas, Lee?
Yeah, this is exactly what we've been saying is going to happen. And all of the data points that this is what's going to happen. All of the sensors say that exactly what we said was going to happen is happening. We have a 13% increase in galactic cosmic rays over the last 2.5 years across the north central part of the United States, and a 19% increase in galactic cosmic rays over the northeast over the same period of time. And that increase in galactic cosmic rays creates increases in nucleation. That increase in nucleation uptakes more moisture when the conditions are correct. And even if you already have clouds that are already seeded and there's moisture there, when increased nucleation comes in, it shares that moisture with the new nucleation, so as that the cloud gets bigger, the cloud gets brighter, and you get much more rapid updrafts, which gives you much more violent lightning, as well as the possibility for atmospheric compression events, rain bombs, horizontal winds 125 miles an hour, in excess of 4 inches of rain in an hour. I mean, these are all going to be commonplace things. I saw a guy on a Weather Channel the other day say, oh, they had a torrential downpour. They had a 1/2 inch in an hour. Well, that ain't squat, buddy. There are people getting 4, 6, 8 inches of rain in an hour. So we need to get used to that, because that's what's coming.
I mean, I'm glad you said that. Pennsylvania yesterday reported 4.27 inches of rain in 1 hour. And I mean, maybe I'm just not paying attention enough, but I didn't see it anywhere in the news. I didn't hear about it. It wasn't on the Weather Channel's short videos. It wasn't on AccuWeather short videos. What's it going to take to get people's attention? Forget about, what the cause is. It's about awareness at this point, because I don't know how much more some of these areas can take as far as water. I mean, we're waterlogged on the eastern part of the United States. I'd say from Illinois all the way over to the East Coast, New England, Florida. I mean, it's soggy everywhere.
Oh, yeah, it really is. And it's only going to get soggier, is the worst part about it. This is just the beginning, because as we continue to drop in our TSI like we have, the galactic cosmic rays increase. And if you look like right now, I mean, we're all the way down to, what are we, 1360.2? Have we come back up that far yet? I mean, when you're dropping down to that, I mean, again, monitor minimum levels are 1360. We're at 1360.2. We dropped 0.5 in a matter of, 2 weeks? Now that will rebound, but it doesn't matter. It won't come all the way back up to where it was. And if it does, it won't be for long, and it'll drop again, because when you look at the charts that we've got on here, you can see the long-term trends of what it's doing. Then you can see what we're talking about. So when we talk about TSI later on in the show, you'll be able to see those charts.
That one. We'll start with that one. Go back up.
This one?
Nope, the other one.
This one?
Yep. Go ahead and put up one of the charts now. The TSI has been fluctuating in the lower part of the 1360 region. I mentioned this a couple shows back. I've been paying attention to it probably since October, and then I got really serious about it in January, and I've always witnessed it flirting with 1360.1, and then it would drop back below 1360.8 or whatever. But here recently, the last couple of weeks, and again, we don't get real-time data from source. It's only 7 days, so it's 7 days old. So basically, the last information we can get is 7 days back. That's the most recent. But my point I'm trying to get at here is I've seen it teeter-totter in the lower part of the 1360 here recently. And we talked with John, and he said that we needed to be worried once we saw the TSI at 1360.
Right. And so we are. And so if you can go to that other chart, we can show the long-term decline. I mean, on this chart on the right-hand side, you can see where we are right now, right down there at the bottom, where we've dropped off. But I think, so this is what I'm talking about right here.
Okay.
Okay. Now, look back, bottom left-hand side of that chart. That's what, April of 2015? Okay. So the end of March 2015, we were peaking at above 1362. Okay. We haven't peaked above 1361, so we've lost an entire watt. We haven't peaked above 1361 since April of 2016. And, you know, now we're dropping and you see these spikes coming down here on the bottom. We're going to continue to drop on as we continue into this. So we're not anywhere near the bottom yet. We've still got more to go.
That's the scary part. And that's when it starts getting a little bit more sobering for me when I see these kinds of charts. When, you know, now you're explaining this and looking at the dips in previous months and years. Yeah, just barely below 1360, but now you're seeing clearly. And solar cycle 25 technically doesn't start till what, around 2019, 2020?
Probably, yeah. And I would suggest that based on historic data, it'll be a minimum of 13 years long. It could be 13 and a half, close to 14. And then the really screwed up part about that is when you come out of 25 and you try to go into 26, by that time, if you follow Valentina Zarkova's work, you'll see that the magnetic fields on the surface will be so weak because they're going 180 degrees out of phase and canceling each other out internally. So you're going to see a lot more CMEs, EMPs, things of that nature that are pulsing out of the sun away from the groupings of the gas giants, just like what we saw towards Mars the other day. And I've got a theory about all of that, and I'm going to run that by some of my magnetic physicist friends and see what they think of it.
Well, but, and I'm glad you said that, because I wanted to ask you about that. And then I've been thinking about what you've said. Would you like to share it yet, or you still want to kind of run things through before you?
I mean, I'll share it because I don't, you know, it's a hypothesis. You know, we all look at things differently, and we all, you know, take things in. And I'm not saying I've discovered anything.
Right.
All I'm saying is if you look at how the sun is in the center of our solar system, and you realize that the sun actually shifts towards the gas giants when they group up. So is that the sun just doesn't really set right in the middle. It actually moves around a little bit towards whatever the grouping is. And so when you have greater than 50% of the planets on one side, especially if the gas giants are all on one side, and then you have all of the gas giants within a fan that's about a 90-degree fan away from, you know, coming out from the sun, and they all fall within that fan, there is a gravitational effect between the planets and the sun. And so if you look at it, there are magnetic fields going around the sun, coming out of the top and leaping out around and coming around the sides and then going down to the bottom and coming back in. And if you look at it kind of like an orange that you've peeled and you see all of the little slices of the orange in there, imagine those are the magnetic fields that are around the sun. And so when you have all the gravitational effect of these planets and the sun's pulling on the planets are pulling on the sun, you would think that some of that gravitational effect would also apply to those magnetic fields and kind of want to pull those magnetic fields towards those planets. In doing so, it would tend to make the side towards those planets stronger and would also partially explain what we always refer to as the Earth-facing quiet. And so as it's pulling all of those magnetic fields towards that greater gravitational field, it's going to leave a slight void in the back side of the sun, or an area that is slightly weaker. So is that when we have a sunspot like AR, what was it, 2665?
Yep.
Okay, so when we have a sunspot like AR 2665 that comes around and it crosses over that area that is somewhat weaker on the opposite side of the sun, because the magnetic fields are pulled this way ever so slightly, you get a CME. And if you look at the one that we had, it was fairly substantial. It was actually really nasty looking. And so, you know, if we were where Mars is now in our orbit, we wouldn't be probably having this conversation right now. So that is the reality of the situation.
Yeah, and when you talked to me about this, you and another YouTube channel were talking, bouncing theories around, stuff like that. So I knew it caught your interest. We did a little kind of background check on the theory on Solar Scope, actually Starry Night, and ironically, the Carrington event, for what now maybe you'll take a look and see it differently, but it almost 100% matches up with the majority of the planets being on one side, representing a stronger magnetic field, and Earth at the time was on the weaker side. So
Gravitation.
Yep. And then we fast forwarded it to this year, and somewhere on, we can agree, it could be August, but I think closer to late fall through February, we will definitely be in that position from what I saw on Starry Night. And again, I'll send you those. We captured the screenshots of where the orbits are, so I'll make sure you get those. You can take a look at them yourself. I want to send a special hello out there to Jordan. Thanks for tuning in. He's from, or they're from my hometown, or back home in Southwest Ohio, near the Inglewood, Dayton area. Thanks for joining in. Wes and Don are good people. But so, again, Lee, this is an interesting hypothesis, and it seems logical.
Well, again, I will have to get with, you know, my friends from CERN and a few other places, and get their input on it. But, you know, everybody has always asked, you know, how can we explain the Earth-facing quiet? And if you look at it, I mean, you know, even light is affected by gravity. So, you know, if we can pull those fields around this way a little bit and make them a little weaker on the other side, as we just saw when 2665 went through, poof, it did it. So we'll see if, you know, the next one goes through and does the same thing. You know, not guaranteeing that it will, but it seems to pan out that that's kind of the way it's working.
Yeah, and by any means, is that what you're trying to say? We're not trying to say, oh, when we are over there, you better watch out, we're going to get the shot. No, we're just saying that the conditions seem to be favorable.
Yes, they're more favorable.
Yes. So it is something to keep an eye out for, but at the same time, we're not trying to say, well, what, the kill shot's coming. We're just saying that these conditions match up from history. Again, Lee has taught me one thing. This research is a lot of it's history based, and it hasn't steered anybody wrong, in my opinion, from what I've seen. So, but very interesting. I can't wait to hear what your findings will be at the end of this. So, anyway, was there anything in specific that you wanted to cover tonight, Lee?
Yeah, I just wanted to go over all of these different slides that we had here that I had sent to you. So, this one here is showing how our TSI has been dropping, back just since April of 2015. So here we are basically, 2 years, 3 months down the road, 2 years, 4 months, and you can see how much we've dropped. And, a watt is something to talk about. Okay. It doesn't take but, another watt and we're in trouble. And, oh, yeah, you can go back to that one. So, or we can stick at this, it doesn't matter. This one we already seen, but this shows the dips that we keep getting. This is our most recent dip of where we are now. So as you can see, we were floating up at 1360.7, 1360.8, floating around in there, and we have dropped off all the way down here to just above, well, basically right at 1360.1. And so, we stagger this, we'll come back up, but, notice the coming out of it is not nearly as steep as the falling into it. There at the bottom right-hand corner, you see that there? So okay. That tells you that it's not going to jump straight back up, and it'll probably fall again.
These are days. My mistake, Mari. I wasn't looking at this chart correctly. What a sharp decline we have seen in the first half of July. Look at that.
Right.
Wow. And okay.
And so you see that coming up out of the bottom right-hand corner there.
Yes.
See that slow rate of incline?
Yes.
That tells you right there that you're not going to go back up sharp, because look at the rate of decline. See how slow they come out? And see, like, if you look at the two humps that are at the top of it, see, so it dropped in and then it came out slow. And then it dropped in and it came back up a little bit and then it dropped again. So there we lost 1/10 of a watt in that one little spot right there. That's the kind of thing that we're going to see, is these little 1/10 of watts kicking away. The problem is we've only got 8 more to go and we're in trouble. Okay, from where we are right now, we only have 1.5 more to go and we're in trouble. And we get, as these sunspots increase, or excuse me, not sunspots, but coronal holes increase, we're going to see more particles coming in, more cloud nucleation. That increased cloud nucleation is going to share the moisture that is already in the atmosphere, and that moisture is going to make much bigger, much whiter, more fluffy clouds, and again, increase more refraction of the TSI back out into space, driving us even cooler. And, when you add up, if it was all just like it was during the Maunder minimum, and you go, oh my God, that was pretty cold. New York Harbor froze. The Thames River froze. There were hotels in the middle of the Baltic Sea, because it was frozen solid. And I was talking to a friend of mine about this the other day. I don't know if anyone is familiar with a little stretch of water on the north side of New York City when you're trying to either go up the Hudson River or you're trying to go into Long Island Sound. But there's a piece of water right there that makes whitewater rafting look like nothing. It's called Hell's Gate, or Hellgate. And if you've ever seen Hellgate, just try to imagine, number one, that's salt water. But two, just how cold does it have to be to freeze that solid against the tide coming in and out? Okay, just imagine that. How cold is New York City that you can freeze Hellgate? So, that's what I'm talking about. It will get colder. And when you see drop-offs in TSI like this is when you see that. Yes.
Lee, quickly, I got a quick question here, and
sure.
This guy, I'd like to get this answered for him because I think it would help him understand a little better. Global cooling, less evaporation, less water vapor in the atmosphere. Where are the calculations that into account?
Okay, when you look at, the first thing I would recommend you do is go look at Heinrich Svensmark's work. Heinrich Svensmark, there's a movie about his work. It's called The Cloud Mystery, and that explains how cloud nucleation works, how cosmic rays and increased cosmic rays drives increased cloud nucleation. Okay, so you take that work first, then go look at Dr. Kirkby's work from the Cloud Project at CERN and look how clouds are formed. It's not a matter of more evaporation, less evaporation. It's a matter of the correct temperature, the correct barometric pressure, and the amount of seeds. Okay, you can have a lower humidity or a higher humidity. That doesn't make that much difference. You only get cloud nucleation and the droplets within a cloud by the particles. So it doesn't matter if the atmosphere is 100% humidity or 99.999% humidity. If there are no particles there, there will be no clouds, because you have to have particles to have clouds. So you can have 100% humidity and no clouds. You can also have 30% humidity, 40% humidity, and still have clouds, because you have the nucleation and the correct environment for it, for that moisture to condense onto that cloud nuclei or seed that is approximately 50 to 100 nanometers in size. And so that is the very beginnings of that. And gases that are also created by cosmic and galactic cosmic rays can also work as seeds for rain droplets as well, to form condensation on it. So it's not just the particles themselves. So it's a double-edged sword when they come in. So you can have and will have less evaporation, but now this is the other thing. 71% of the Earth is water. Now, where can you go on the ocean that you don't have almost 100% humidity unless you're in an Arctic type environment? So there's always plenty of moisture in our atmosphere to support the cloud nucleation. And if you listen to the interview that I did on Adapt 2030 with David Dubine, he flew in from Asia and flew into the United States and flew back. And basically the entire time he was over the Pacific Ocean flying in, he never saw the water at all. It was basically cloud cover from one side to the other, because we have the cloud nucleation coming in from the galactic cosmic rays. We have the increased ship traffic putting more aerosols in the air. We have aircraft putting more aerosols in the air, vehicles, other, fossil fuel, and even termites. I mean, termites put out a huge amount of particulate as the wood breaks down from the termites. And that gets into our atmosphere. And again, the galactic cosmic rays interact with that. And so it's not, again, so much. So if you look at Dr. Kirkby's work from CERN, he will explain in his lecture, and that lecture is in my playlist of Dr. Kirkby's lectures. I think I only have 5 from Dr. Kirkby, and I think that lecture is about an hour and 26 minutes or something of that nature. I believe it's the one from 2009 is the one that is most comprehensive on how cloud nucleation actually transforms inside of their chamber with the barometric pressures and so on and so forth. So I hope that answers this question.
Yeah, I'm sure it did. Another question from the chat. With TSI dropping off, will there be a greater chance / probability of CME, EMP type events?
I don't apply that to the TSI falling off. I do think there is a greater chance of CMEs and things of that nature because of the fact that these two magnetic fields are going 180 degrees out of phase. And anytime you put things 180 degrees out of phase, periodically there's times where things just don't quite fit right, and things are going to launch out to the sides with those magnetic fields. So I see definitely an increase in instability of our sun. And if I follow Valentina Zarkova's data correctly, I think she also believes that there is going to be increased instability within our sun. And her data shows, and her data is gleaned from Wilcox Observatory in California, which has been monitoring the magnetic fields of the sun, I think, since 1953. So she's got good data. A lot of people have backed that up and proven that she's right, or at least, done the same math and said, yeah, it all makes sense to us. And when you look at how accurate it is on being able to predict back and predict forward, it's extremely accurate. So when you look at what she's talking about, it says that there will be increased instability in the sun. And from experience in working with magnets, electromagnets, and supermagnets, and things of that nature with generators, alternators, and motors, I can see where, yeah, there can definitely be some instability with the sun. So, yeah, I would be more concerned.
Looking at some of the comments in the chat, Daniel says, make friends with a farmer. That's
absolutely.
Mad Netter made a statement here about 85% of the globe has cloud coverage currently. And Mad Netter does a lot of observation with International Space Station cams. So is it really at 85%, or does it just look like there's so much that you just can't imagine it being less than 85%?
Well, I haven't, since my incident on the 7th, I haven't been reviewing the amounts of cloud cover like I was previously. But just in the two photographs that I had sent to you, we had already seen, I think, a 13 or a 14% increase in cloud cover back then. So do you remember when I sent you those two pictures? What was that, a couple months ago?
Yep.
Okay. So, with what we already had, I can't say we're at 89% cloud cover because I haven't looked at it. But I can easily say that we're up by at least 13 or 14% over what we were just a few years ago. So the nucleation is taking place. I haven't seen the data to substantiate that. And I'm not saying it's wrong. I'm just saying I haven't seen anything that says that. And again, I haven't been looking at that for a number of weeks. All I know is that it has been increasing dramatically. And people are telling me that it's a lot worse than what the reports are saying.
Well, 85% is what he says, and that's what it feels like every day when you look up in the sky. 85% to 100% cloud coverage every day. I haven't seen a clear blue sky day for the whole day like we used to. I haven't seen one in now it's been at least a year for me.
Well, for where we are down here, I've already done the research, and for May, June, and July, so far we are a full 2 degrees Fahrenheit below average for those 3 months for this location. And then I've done more research on it and found just the other day that our daytime high was actually below the normal low for the day. So, it's you can see the effects here. Other people are seeing it around the world. The Russians are already putting in indoor growing facilities in Siberia and other places, and they're already preparing their military, as well as Pakistan and India and other countries like that are preparing. China is a major preparation underway, and they're buying up land all through Africa and putting in railroads that go to nowhere, but they actually do. They go to the fields that they already have planned to start growing crops there to support their population.
Someone asked about snow in Russia during the summer, but that's actually a lot of the reports of snow in places like Russia is actually hail. Lee, could you tell us, what is causing all these hailstorms?
Because we have atmospheric instability, the jet stream is freaking out. We've got this rain that gets thrown way up into the sky very rapidly, and it forms these hailstones and falls back down because there's more nucleation. It's got a greater velocity in the updraft, and instead of floating up and turning into snow, it shoots up and turns into hail, and then comes pouring back down on top of us. And then additionally, when it does that, if we've got cooler air above that, it'll pull cooler air down into it and create even more. But just a simple fact that, they've got snow. I think was it in St. Petersburg or was it Moscow yesterday?
St. Petersburg.
St. Petersburg, yeah. So, they got snow in St. Petersburg yesterday. That's not normal.
But it was hail.
Okay.
From what it's hail, but people are mistaking it for snow.
Well, the one video I saw of it, there was definitely snow in the video I saw. I'm not saying there wasn't hail in other parts of the city, but the one video that I did see, there was snow in that one because he was driving down the road and you could see it blowing across the windshield. So there was definitely snow with it. So, but it's absolutely insane. I mean, Spain's getting nailed, twice now? South America's getting nailed. And John Casey predicted the earthquakes down in New Zealand and so on and so forth months and months ago, and they just had those. So their prediction models are coming out true. And all this is based on historic facts and data going back over 20,000 years. This isn't anybody's idea of, oh, we think this is going to happen or it could possibly. No, we're saying, look, this thing has done it all these times. I mean, it's just like this. And I was thinking about this earlier. Everybody knows what Old Faithful is. So if I told you that you've got to go stand over top of Old Faithful and you know that it's going to go off at a certain time, wouldn't you prepare and put something on to try to protect yourself from Old Faithful? Well, that's just a cycle that Mother Nature does, just like what this is, except for the sun does this cycle as opposed to Old Faithful, which, by the way, Old Faithful ain't faithful no more.
Nope.
She's not nearly as faithful as she used to be. She's been out messing around, changing her times up all the time. I mean, I got friends that work out there, and I asked them what they thought, and they're like, we got no idea, Lee. It'll go off when it goes off. We don't even bother trying to write it on the board anymore. We've been so wrong so many times, we just give up.
Yep. I see a lot of comments here. Wayne from Ohio, rains a lot. Wind, it's different kind of rain and wind. It rains in sheets. That's just, again, all the highly charged particles that are in our atmosphere right now due to our weak magnetosphere. And there's more particles in our atmosphere. So when the storm systems come along, there's more rain. Particles make clouds and rain. So that's why we're seeing a downpour. It's the same, the common comment I keep seeing over and over again. We're not used to seeing it like this. We've never seen this before. And what I was going with this, with the TSI dropping and the increased cloud coverage, and last month in June, reported a loss of 0.21 degrees Celsius.
No, down to 0.21.
Right.
It has dropped to 0.21 above the zero line.
Right. So I'm only curious to see the continuation of it dropping into July. We're a few days away here till August 1st, so we'll have that data hopefully as soon as possible. But I'm eager to see the trend on this report. I know just here, now there's parts of this country that's heated up over July. But
absolutely, there's high pressure areas that are causing that. But when you look at it, it's not records. Warm records to cold records is, what is it, 1,800 or something to 1?
Well, it was 18 to 1 a few weeks ago.
18 to 1.
I don't know
excuse
what
me.
that number is
18
now,
to 1.
But a few weeks
18
ago,
to 1. there was 1,800, I think, records broken, but it was, or whatever it was, but it was 18-to-1 cold records being broken to warm records being broken. That's a pretty good ratio to tell you that we're getting colder if the cold records being broken are 18-to-1 over hot records being broken. And you've got the rest of those slides up there. Let's go through those before we get too far into this.
Well, one of them was disapproved by our producer here.
But I found a higher res version, so it's back on.
Oh, so
That's
never.
even better.
It's
You know,
back.
Well, the one
So
I didn't. The one I'm not happy with the resolution, but I'll just suck it up and deal. But I will put the one on that I got higher resolution.
Yeah, that's great.
Well, maybe I didn't.
So yeah, that's the one with the lower resolution.
I gotta be honest with you. I gotta stop this real quick. I gotta be honest with you. Darn right. I don't know. He's asking us, where are we getting this data? Normal temps here.
Some people don't understand. It's
Okay, so this data right here comes from a combination of deep lake core sediments, ice core sediments, tree rings, coral reefs, pine cones, 17 different data sets put together by Jasper Kirkby and his team at CERN from data that has been gleaned from all over the world over the last 50 years. So that's what we're looking at. And so when you look at that, I can't exactly read what the temperature variances there are on the bottom of that scale. Maybe you guys can. But in the show the other night, we were talking about how there's a cold stripe that comes down across the middle part of the United States. And that you could see that cold stripe. And that is the area, yeah, right there. You see that dark blue coming down across the United States? So that's, what is that, 0.7 degrees Celsius change?
What is this from?
This is from, this is a cold weather climate of what the Earth's temperatures were from 1680 to 1780, basically during the modern minimum period. And if you see there in the dark blue all the way to the left, that is more than minus 0.7 degrees Celsius. So it's well over 1 degree Fahrenheit, could be up to 2 degrees Fahrenheit difference in that area where that dark blue stripe is. So now when you look up across Russia and across Europe over there, see that giant dark blue up there? Now you see why they're so worried. And you also see why I say that one of the best places in the United States to be is down in Florida, because look right there from the Gulf of Mexico on the western coast of Florida, across Florida over to the eastern shore of Florida, you're all still in white. So that is an area that will not be as adversely affected as the rest of the country, as you can see. And there will be, because of the way that the colder air is going to come down and be interacting with the warmer air coming up from down south, you're going to have massive amounts of rain, cloud nucleation, cold weather, hail, earthquakes, volcanic eruptions, unbelievable lightning. And do we have the chart that shows the voltage potential difference between our magnetosphere, ionosphere, and space or the Earth?
It's probably because it's on a delay, but that is what's showing right now. I have no way to alter that in any way since the map is up online. Yep. So
sorry, I just had people saying that
they have to click the live button
Gotcha.
if they want to see it. Maybe they're behind, lagging before the image switches. I don't know. But we're live and things happen.
Sorry about that, folks.
Yeah, the map is what I see.
Okay, so Lee, what did you want me to put up next for you?
Do you have the one that shows either the drop off in the solar wind speed or the drop off in the voltage of the ionosphere?
I only have 3 charts.
Okay. Well, don't worry about it then.
And then I have the one map with the temperatures. And then I also, I have the stratospheric radiation
Yeah. Look at that.
chart as well, but it's not
Yeah.
the resolution sorted.
Yeah, I'm sorry, but they can see the curve. Well, then that's not the one I'm talking about.
I'm sending it
I'm
right
sorry.
now, Maureen.
Jake's gonna send it to me, so.
Okay.
This one is kind of important, so I'm going to make sure she gets it right now.
Yeah. Okay.
I know you wanted to talk to me about this.
Yeah, I wanted to talk to you about the magnetosphere and the ionosphere and the voltage potential difference of that, and then also you can actually see the solar wind speed is also dropping dramatically in its average speed, which neither of those is good news, because what it amounts to is, if you look at the Earth's surface as ground, okay, electrically, okay, yeah, so here you go. So this is, and I just can't quite, okay, so you can see that the wind speed is dropping off. Look over on the right hand side of the chart. So you can see how that trend, so if you go from, and I can't zoom it in, but you can see that trend on the right hand side as it's trending down. That is the wind speed coming from the sun, and that's not a good thing for it to be trending down like that, because that shows that the sun is getting weaker. The other thing is, there's a voltage potential between us and space, and I can't remember off the top of my head right now. I'll have to research it again to be able to give you the exact numbers, but it's tens of thousands or hundreds of thousands of volts, whatever it is, between us and space. And so there are different layers in our atmosphere, in our ionosphere, magnetosphere, as it goes up. And there's different voltage potentials across those different layers. So let's say that it's 5 layers, and let's say, and this is just, I'm just throwing these numbers out here for easy math. So let's say it's 5 layers. Each layer has 2,000 volts on it. So it's 10,000 volts between here and space. Okay. The problem is, if a couple of those layers, instead of having their 2,000 volts, if they drop in their potential, that means that there is a greater voltage potential across the rest of the circuit from us up to space, which means that the lightning bolts that you see now are nothing compared to the lightning bolts you're about to see. Pay close attention to what the claps of thunder sound like. When there's an electrical storm, go outside or stand next to a window, and look out and watch the storm, and physically look at the size of the lightning bolts. You will see that they are getting bigger. You will see that the claps of thunder are starting to knock things off people's walls, and they're killing more people, destroying more infrastructure, damaging cars, damaging ships, damaging trains, anything this stuff is hitting. And there is just this week more research to prove plasma geology, plasma geology, because they actually found fossils of living creatures that were hit with giant electrical charges and basically ionized them into stone instantaneously.
Wow.
And so that is a report that just came out this week, that they have found these things. And I'll try to get the link to that so as that we can put it in the description. And I have been following plasma geology for some time now, and I have actually seen rocks that actually represent what that looks like, the twisting of the current coming in. I've got a picture of a rock. I'll send it to you so we can put it up on another show, of where it looks like the 2 currents, like 2 Birkeland currents side by side, are twisting, and they come into, it looks like a piece of granite, and it's ionized that corner with perfectly smooth twist that comes out about 8 to 10 inches. that's probably 6 inches in diameter. So there's more evidence of this is taking place. And if you are making variations in your magnetosphere, ionosphere is in the voltages across that's going to change the patterns of lightning. And we're also seeing more positive lightning, which is lightning that strikes from higher up in the atmosphere down, and they're way more powerful. And when you're listening to lightning, or watching lightning and listening to the thunder, as you're listening to the thunder, you can actually hear the difference in those positive lightning strikes from the regular negative lightning strikes. And then additionally, we've got the lightning strikes that are arcing up out of the ground, like they had, what was it, in Oklahoma the other day?
Yeah.
You had those pictures?
That was incredible. I don't have them, but I've seen them. It looked like picture this, a tree upside down and the roots were in the sky. That's what it looked like. The ones that I saw.
So as you guys can see in this graph here, you see how it's pretty much level. It's been level all the way across until you get, 3/4 of the way across, and then you see it starting to slope down, and you see the really low area there in the middle, even beyond that drop right there. That is what I'm talking about as far as, I always say that this thing is like a roller coaster, and it goes up for 176 years, and then it drops very steeply for 30. And so I've been telling everybody, it's like that roller coaster has been going over the top of the hill, and now it has. The last car has crested the top of the hill, and it's nothing but acceleration from here on out. And you can see that represented on the right quarter of that top chart there on the right-hand side. You see how that, if you draw a straight line between all of those peaks, and then you look in between them and you see how low all of those, you'll quickly realize that the average is even below what you see on the right-hand side. So we're falling, and that is a sign of the coronal holes are going to get larger, they're going to get darker, it's going to get cooler, we're going to get more particles coming out of the sun that are spewing out of those coronal hole streams, which is going to drive us even cooler than we were, because we've got so much more particles in our atmosphere as a soup for those cosmic and galactic cosmic rays and solar particles that are streaming out of those coronal holes. Did you have the other slide, or this is the only one you had? Did we lose you there, Jake?
Oh, you muted me. Sorry, Lee. Yeah, those are all the slides that I had sent to her. I thought those are the ones you wanted to use for tonight.
Okay. Yeah, that's fine. We got through them, and we got the important stuff out there, and we do have those other slides. If anybody wants to see them, we'll put them up in another show.
Yeah.
So,
but you were talking about
go ahead.
You were talking about coronal holes being plentiful, and again, those only form because of the weak corona. So as we go deeper into this grand solar minimum, what we're saying is this is just the beginning. We're not even really in the beginning. We're getting there. So
yeah, we just got the truck started, and we're going on a cross country trip.
Yeah,
I can't. Or we're going to sail around the world, and we just weighed anchor. So, and these coronal holes will continue to get bigger. And what people don't realize is coronal holes. I mean, we used to have them, but like they were rare and really, really small. It's only been, like in really the last few years that these things have been getting monstrous like this. And that is definitely going to be creating additional cooling, because coronal holes are not as warm or as hot as areas where you don't have coronal holes. And then in addition to them being cooler, they're just spewing out particles. And those particles are putting more particles in our atmosphere for increased nucleation. So, I think these coronal holes over time are going to play a much more significant role in what's ahead than what anybody has thought that they would. I mean, everybody says, oh, the sun's going to do this, the sun's going to do that. And yes, it is. But nobody is talking about the coronal holes and how they are contributing to this. and how much worse they can make it based on what we're seeing now. Because I don't think all the stuff I've seen, I haven't seen anywhere where they said, oh yeah, we've got galactic cosmic rays, we got all this, we got all that, and oh, by the way, we had these monstrous coronal holes that were taking over the sun. You know, I haven't seen that.
And these coronal holes, I wanted to talk, and thanks, Mari, for bringing this up, putting this up, because I wanted to ask you, Lee. We have now monitored this coronal hole that's north of the equator, equatorial region of the sun. Now, to my understanding, Earth, anything in the dead center of the sun, we get direct impact from, because that's where Earth is on the sun, in the equatorial region. So when we have these coronal holes that have formed above that area, what we're experiencing right now, the solar winds we're getting are brushing against our magnetic field. This solar wind speeds have been elevated in the 600s since the 21st. It's now the 24th. Have this been further south? Have this been further south, Lee? What kind of would there would definitely be a more intense effect, and the winds would be obviously a lot faster than what they are now.
Correct. Well, we'll say a lot faster, but they would be faster, and the density of the particles would be higher.
Okay.
See how it's dark up at the top?
Yep.
That's the even cooler areas, because that's what we're seeing, and we're seeing, you know, the lack of those charged particles. And you see how it looks like it's hairy on the sides, but it doesn't look hairy on the top, and it's barely hairy on the bottom.
It's got the George Jefferson look. Yes.
Right. Well, you see how thick it is on the right-hand side?
Yes.
The whole sun's supposed to look like that. Okay, that tells you just how weak it really is. Okay, I mean, look how, I mean, that is just showing the weakness of the sun, is how it's continuing to get weaker each and every day as you watch it go around. I mean, it's actually saddening to see that this is happening to our sun, and realizing of the impact that it's going to have on the population of this planet. You know, to see that it's getting that weak, and you can see it in all spectrums. See that? It doesn't matter what spectrum you go to, that hole is there, and you know that's cooler. When you've got holes like that, that area is cooler, and our TSI drops. So you know, imagine if you had a great big one of those coming around in front of the sun, TSI would drop dramatically during that, and that's what my concern is if you see how big that is and how dark that is. You saw what just a couple small sunspots did going across the face of the sun. Can you imagine if you had a great big one of those that took up, say, like a third of the sun right around the equatorial region and went across? Yeah. I mean, we could lose 3, 4, 5 watts of TSI if something like that were to transpire. And that would be taking place over a week or so. You know, maybe even 2 or 3 weeks, depending upon how long it was and, you know, and how big it is, and how it's spanned across the equatorial region of the sun. And so these are the concerns that I have, you know, going forward that, you know, people aren't talking about. And, you know, nobody is. I mean, we got Dr. Casey to touch base on it the other night in the interview, and, you know, agreed that, yeah, they will. It is a cooler spot on the sun, and it can decrease TSI. But, you know, to what level, nobody can predict at this point. All we can say is that they look like they are getting worse. The data shows that they are getting worse. And if you follow Valentina Zarkova's work, which a lot of people do, including myself, it looks like that it says that they're going to get worse there as well, plus the increase in the amount of CMEs from the instability within those opposing magnetic fields. So it's going to be a rough ride no matter how you look at it. We just all need to be prepared for it.
Lee, I got a question out of the chat I wanted to ask you real quick. I don't think I've ever seen this kind of question phrased before like this, but we got time. So have you considered that the Birkeland currents at the poles of the Earth cool the planet?
No. The Birkeland currents feed energy into the core of the planet, which actually heats the core of the planet. The cooling that we are getting is from the galactic cosmic rays interacting with particles within our atmosphere, creating nitric oxide, and that nitric oxide is dropping the temperature and I can't remember what layer it is up there that it's dropping in, but it's dropping the temperature, and we see that on the satellite data. So it's not in my opinion, it is not the Birkeland currents by any stretch of the imagination. It is the gases that are being generated by the nucleation from the cosmic rays that are generating the cooling. And that's a report that came out from NASA in December, from Goddard and a couple of other universities, some in the Washington, D.C. area. I think somebody out on the West Coast, Berkeley, or somebody was also involved in that research. And a quote from the head researcher from NASA said, it's basically like a giant air conditioner in the atmosphere that we can't cut off. And so shortly after that peer-reviewed paper was released, it has somewhat been very difficult to locate again. So if anybody can find that again, we would very much like to attach that to this show.
It appears that everybody's got their speculation. Honestly, if we sat here and went through each speculation of theory, we would I don't know, we'd probably run out of internet time to stream that. But you know, let's focus on the big picture here, folks, and that's raising awareness of the change in our climate and the way we have to adapt into the future, because this is only the beginning and we're not even into the minimum yet. We're just at the very beginning. So I'm not trying to disrespect anyone with their theories on why it's cooling or how it's cooling. The problems that we're facing right now are real. They're not made up. These aren't fiction stories. These are actual events that are taking place right now. And it was interesting to watch the TSI drop in July between the 2nd and the 9th, and noticing also the story that Mari covered earlier, the 6 named Pacific hurricanes. So just watching the TSI drop, I remember, is there a correlation to extreme weather events when you see a drop in TSI that sharp?
Yes, yes. And it goes back to, where everybody was trying to debunk me on. I was telling everybody, if you look at the TSI and you look at all the worst blizzards, we were always down low on TSI or just coming out of a low on TSI when all of the worst blizzards in history have taken place. And people said, oh, well, you don't have data back past whatever it was. Well, actually, we do. We've got it all correlated now, going all the way back to, I think it's 1610. So you can look at every single major blizzard. It's all approved, peer-reviewed, how they cross-referenced everything with the tree rings and the ice cores and the deep lake sediments, ocean bottom sediment, stalactites, stalagmites, coral reefs, pine cones, you name it. All of that's correlated all the way back to 1610. So we know what the TSI was. We know what the carbon-14 is prior to the atomic age in the United States. So we have very good records of that. That's also all correlated, as Dr. Kirkby says, exquisitely in one of his lectures from 2009. And so you can see all of that correlated there. And we're not making predictions.
No.
We are taking the data that shows the history of what happens. And all we are doing is taking that data and saying, look, you've got an 80% chance of that, an 80% chance of this, an 80% chance of that, 100% chance of this, of what all of those are going to be. And all of everything that we are talking about is all based on historical records showing what has happened every single time one of these happens. It's not a matter of, we think this is going to happen. We know this happens. Just like Old Faithful goes off, this is going to happen. It's a cycle. It happens every 206 years, and we can go back over 200,000 years. In fact, there's people that went way, way, way farther back than that. But 200,000 years is more than enough information for me to look at how the sun operates. In fact, just the last 20,000 years is more than enough to show the pattern. And the thing that gives it away is during the peak of the solar cycle, you have 2 peaks. And the second peak in the solar cycle is higher than the first peak. And anytime you do that, you go into a Maunder type event. And you can look at every single one of them in history, and they all do that. So for this one to be any different, not really, because the data shows that the sun is doing exactly the same thing it did the last time we had a Maunder type event or a grand solar minimum, because all grand solar minimums start out with two peaks, the second one being higher than the first. So that's proven. That's how it works. That's RC theory. That's accepted. And if you don't want to accept it, there's nothing we can do about it. But that's the facts, folks.
I want to share a little story real quick here, and it's cute because I kept it private. I didn't want to talk about it much until today's press release. For those of you who don't know, I'll get into the details of the press release here just a second because Mari knows more of the information. I briefly looked at it. I watched the video. I got a comment right after we did the interview with Mr. John Casey, and how I announced Mr. Casey as the president of the International Earthquake Volcano Prediction Center. And the comment was very snarky. The person that wrote it apparently feels that he is more established and is better at predicting these events than Mr. Casey, and made a very disrespectful comment stating that he compared the International Earthquake and Volcano Prediction Center to the USGS. That was his comparison. And then today we get this press release from the International Earthquake Volcano Prediction Center. Mari, what was the success of this press release today?
It was like 100% accuracy, wasn't it?
It was 100% accuracy. And where was it they predicted these earthquakes?
One was in New Zealand, and the other one was in, I forgot. You caught me off guard.
That's okay.
Researching something. Where was that other
One was in New Zealand.
I can pull it up.
Yeah, I can't remember where the other one was.
But the point I'm trying to make is, and this kind of goes back to a comment I made a few minutes ago, I'm not interested in predictions. I'm not interested in forecasting weather. Lee and I are reporting the data that we review, that we research from the people that we trust, because the people that we trust have been doing this for decades. So again, we're not here to predict, but to be disrespectful, and that's one of the reasons why I never posted the comment, because Siberia. And both Mr. Casey is the president of the International Earthquake Volcano Prediction Center, and his organization predicted 100% correct on earthquakes in New Zealand and Siberia.
The stats were they expected a 7.0 less than 40 kilometers depth offshore of this one particular area, and the actual quake did occur at a depth of 15 kilometers at a magnitude of 7.7. So what was the other one? New Zealand, they original earthquake 2017.
But the point here is that this person also has left many comments on our page about how a junior high science student could predict these events. Okay, so to me, it's almost like before we even discussed John Casey, this individual was minimizing and disrespecting what Mr. Casey has done for many years now. But my point is, instead of coming over and telling me who did it first or who's better at it, please be a part of the solution, not a part of the problem. Not a part of the. We have enough divide and conquer as it is in this country with politics and everything else. Let's do something and be a part of the solution instead of tell us on why we're not 100% correct because you have a hunch about something or you have a hunch. Again, folks, if you don't disagree, that's okay. And if you do have a theory, let's see the evidence and prove it, and that's fine too. But I just want to be clear. We're not here to convince. We're just here to report. And you do what you need to do with the information. If you're convinced, great, we're doing our job. I feel like we should be convincing people because this data is alarming. If we're not convincing people, we might have a problem with the listener, or we're not communicating it well enough. And I hate to be so frank, but I just want to make sure that we're clear that let's be a part of the solution instead of worrying about complaining about not being 100% accurate on this or predicted on that. Again, this individual is big enough to where he shouldn't have to worry about if there's other players out there who are trying to raise awareness, who are just trying to help. That's it.
Well, I get people complaining, well, it's just a hailstorm, Murray. Why are you complaining? Like, why are you reporting about that? That happens all the time. But the problem is we're tracking the frequency and the extreme.
Right. A hailstorm that gives you 3 or 4 inches is one thing. A hailstorm that gives you 4 feet is totally entirely different.
4 feet.
Yeah.
So, I mean,
Okay. So, you know, yeah. So what? Hailstorms happen all the time. I agree with that completely. Do 4-foot deep hailstorms happen all the time? Do hailstorms that dump so much hail that flood an entire city happen all the time as the hail melts? No.
Knee-high water in the streets.
Right. From the hail melting.
So, I mean, it's sorry for again, folks, it's not that look, if you agree with us, great. If you disagree, that's fine. You know, continue to do your research and we'll continue to do ours.
Yeah, we're just bringing you the news that's, you know, unbelievable. We're not talking about 4 inches. We're talking about 4 feet.
I don't think talking about it hurts anything.
No.
I mean, it's just bringing awareness.
Yeah, we're here to improve their situational awareness.
Exactly.
Make them aware of what their surroundings are and how the world is changing before their eyes.
And I guess all I ask is if you do disagree, just be respectful because there's a lot of people here on
Well,
this
show us
channel.
the research that backs up your claim.
Well, we don't even want to argue it. I just
Well, no, we don't. But if somebody wants to say that this is wrong, I would like to see what their research is based on. I have no problem in debating anybody on this because I've got the research to back up what I'm saying.
Well, and I agree with that statement, but my point is that I want people to respect each other because this is not a game. We're not trying to gain any notoriety for any of this. We are simply here for awareness. We've worked very hard this channel. Lee has too. And guys, look, the only reason why we have people like Casey and Lee and Zarkova and Kirkby and Svensmark, the only reason why is because they have put so much time into their research. Okay. I would not bring this to people if I really didn't believe it wasn't true. And the integrity is the most important thing, especially when it comes to YouTube anymore. And everybody out there knows what I'm talking about. People like to exaggerate to get clicks on their videos, call things kill shots when they're not kill shots. So, you know, just be respectful, folks. There's a reason why we believe what we believe from our research, just like the people who believe in global warming. But Lee is open to debate and will politely provide his information versus yours anytime. So, again, maybe that's something we could do in the future. If anyone's interested, maybe have something organized between Lee and yourself. Email me at jake@thegrandsolarminimum.com. And as long as you're bringing credible evidence to the table, we'll be more than happy to hear what you have to say in a private hangout. And
yeah, you know, we want peer-reviewed stuff that we can research, and so that we can talk about it. You know, we'll talk about anything that's peer-reviewed, anything that's active research that is peer-reviewed, and what we refer to as not settled science, but basically a common knowledge science or known science. You know, like water boils at 100 degrees Celsius. So yeah, if it's known science, we've got no problem talking about it.
And people in the chat earlier had said that it's really hard to find information on all the flooding. It's not just something, and that is part. And this is where you might say, "Oh, they're conspiracy theory now," but this is where we feel like the information is being snubbed out.
Well, I did it. The one hail video I posted when we researched it, it was on a media blackout, and I have since looked and reviewed some news articles. I believe we posted it July 5th. When it started really actually coming out into regular media, it seems to be on the 18th, 15th.
Yeah.
So it took 10 days to report such a, you know,
amazing,
you know, you know, biblical kind of hailstorm.
And what about the flood wiping away the temple today?
Yeah.
Well, I mean, we haven't even talked about that. How long has that thing stood there?
Well, that one was built in 2009, so that was a recent one, but they built it far enough. Here's the scary part about this, guys. They built that thing far enough from the river back in 2009, but so much erosion has occurred since, and especially here in the recent months, it's revved up. So we're not just talking about floods here, but we're talking about land that's eroding.
Yeah, and the crazy part about this is you have parts of the world that get wet and parts of the world that get dry. I mean, during one of these events, I think it was India, didn't have a drop of rain for 2 years. What do you grow if your country doesn't have a drop of rain for 2 years?
Right.
You know, and you can look back through the historical records of rainfall, extreme drought, historical records of extreme drought in countries, and I believe it's India, went for 2 years without a single drop of rain. How many billions of people live in India? You know, hundreds of millions, whatever it is.
Well, just like this year, we've had 2 different states in the United States this year lose almost the entire drought in about a month's worth of, and Florida still, my God, you guys are in the surplus now. You have to be now. I mean,
oh yeah,
there's no way. Every day you call me, you have a different lightning story to tell me about and the thunderstorms that you're getting on a daily basis. Almost a daily basis.
It is. It's ridiculous. I mean, when we're in our rainy season, but I mean, it's more rain than you can imagine. It's like, you know, the night we did the show with John Casey, after the show, we got 1.17 inches of rain in 18 minutes.
My goodness.
I mean, that's putting it down. We got, you know, a gully washer here this afternoon. So, you know, everything's full. Everything's plenty green.
When you say 1.17 inches, you know, that's a normal rainfall in a 24-hour period of some steady rain over a 24-hour period. That's some moderate heavy rain at times. So think about the last time that you had a weather system that created rain all day and most of the night, and it was heavy at times and let up a little bit. You know, to get that amount in 18 minutes is insane. And I don't want to hear that. There's nothing normal about it. And Lee, you really opened my eyes about it, because I made the comment, well, you're in South Florida, the moisture down there, that's more believable. And you were like, no, dude, 1.17 inches in 18 minutes is a lot of rain at one time. It doesn't matter where you are. It is.
Right. It doesn't, makes no difference. I mean, the only time it doesn't matter if you got 1.17 inches of rain is if you're on the ocean, you know, or a lake. But other than that, if you're on land, it's an issue. And I mean, but that's nothing. Look at when we go back into last year, what happened to West Virginia, where I think it was 54 out of 56 counties, all but 2 counties in West Virginia were declared a disaster area, where they had floodwaters that were in some places 150 feet deep.
Jeez.
Okay. I was back in there with the American Red Cross when Hurricane Fran came through and washed all that out. So I've been to 2 major floods in West Virginia, supporting the National Guard, the governor's office, and the American Red Cross to go back in there and do disaster assistance. The floods that we had back in the late 90s were nothing compared to what they just got back there. And, you know, like I said, you know, they got in some areas, I think it was 12 inches of rain in that storm. So can you imagine, you know, what kind of flooding you're going to have when you have that? And that's what's happening around the world. It was just our turn, and we got nailed right there in West Virginia. And because of the mountains and, you know, the narrow valleys, it's very devastating to that type of a terrain or topography. So,
and that's the key word you said there, Lee. It was our turn. This is a regional event right now. This is not something that's going to be global. Everywhere is going to experience the same exact result at the same time. And I think a lot of folks that are confused about what's going to happen, they're expecting like to look out the window and you have the same results as someone does 1,000 miles away from you. And it just doesn't work like that right now. And it's one of those things where you'll have to see to believe, I guess, but it's going to be regional to begin with. It's not going to be the same everywhere.
Well, and what it all comes to our turn. I mean, it's like I said, you know, Spain's getting nailed now. We've got a high pressure area over us, And there's 3 storms in the eastern part of the Pacific and 3 storms in the western part of the Pacific. That's the highest number since I think 1974. And if you go back to 1974, ta-da, we're kind of in a minimum back along in there too. We had really cold weather and blizzards, and all of these things kind of go together. So when you look back at it in history, I mean, look, it's the people that don't study history that are doomed to repeat it. So all we have to do is study the history, and all that we're bringing to you is the history of what this does, and so it's there, and it's easy to look at and easy to see, and it's all been brought out for us through massive amounts of research through multiple different organizations around the world. So the information is prevalent, and I have I think it's 174 videos is what I had listed, but YouTube has been delisting some of them for us and removing the videos. So I think we've dropped back to like 140, but there are 140 videos just on one of my playlists of the Grand Solar Minimum or the Big Picture that are all supporting evidence of everything that we're saying. You can go there, there are peer-reviewed papers, or there are other experts in the field who are accredited talking about exactly what we're talking about, be it proving that CO2 does not warm the climate substantially against the cooling created by the refraction of the cloud nucleation. So, I mean, we have the data to back it up and prove it. And we're more than willing to share it, which is basically all that we're trying to do, is share the knowledge that we have and create a colloquium or more like a brain trust of all of the true information and documented and provable information that we can acquire and put it together in one large library in as simple a form as we can, so everybody can understand what's happening and prepare accordingly, for where they're at or what they can or cannot do with them and their family. And look at the maps and look at the historic data to see what your weather was 200 years ago, if you do have weather for that, or look at the charts that have been put together based on the deep lake sediment from lakes all over the world.
Yeah, and this recent CME, also, I'm surprised no one else has mentioned this that I know of. Maybe I'm wrong. Maybe there was other channels. I haven't had time to really pay attention to what anybody else is doing. But the CME that we had on the 23rd marks the 5th year anniversary of a solar storm that we had back on July 23rd, 2012. So again, when we talk about the sun and cycles, it's not an exaggeration. It literally does happen on cycles. But Lee, I want to share one more thing before we wrap it up. A friend of mine found out that I did a YouTube channel, and he asked me what it was about, and I told him I researched the Grand Solar Minimum. And he said, "What's that?" And I told him it was a cycle that involved, involved our sun and our planet's climate. And his next question was, "Well, does it affect me?" I said, "It will." He goes, "Well, if it doesn't affect me now, I don't really care about that kind of stuff, so I'm just going to keep living my life the way I am now." What do you say to somebody? Now, I'm not trying to be weird with him. I don't want to make it awkward, but how do you communicate to a person who's just not even willing to even take even 2 minutes to listen to what you have to say? I mean, that kind of behavior is it's almost a death warrant.
You can't. It's it's like it says in the Bible, don't preach upon deaf ears. All we can do is tell the truth and hope that people will be open-minded enough to be able to do the research themselves or listen to what we're saying. I mean, I added it up the other night, man. I'm coming up on 7,000 hours of research on this one subject, so another 3,000 hours, I can consider myself, I've pretty much mastered it. And I've got a little bit more I need to learn on plasma physics and a little bit more on particle physics, and the creation of gases and how those molecules are formed. But other than that, and a couple other little things here on currents, and I want to know a little bit more about some other people's theories on earthquakes. But that's about all else I want to cover.
Let me wrap up my point before I lose my thought here. And the point is that, and Lee, you said it best, don't preach upon deaf ears. Folks, all you out there who are trying to spread truth and trying to help people understand, just remember that. Don't spin your wheels. It's not worth arguing with friends and family over this. All you can do right now is do the best you can for your friends and family, the best you know how to. If people are going to give you a hard time, it is not worth the argument because there's too much energy wasted in that. You have to start thinking about solutions, and people that don't want to be a part of the solutions, unfortunately, they might have to learn the hard way. So I know that might sound a little cruel. That might sound a little short, but at this point, Lee, that's am I correct on saying that?
Yeah, spend that time preparing and planning for yourself and your family and your loved ones. I mean, if you want to try to stress it to somebody, try to stress it to somebody that has some scientific background and has an open mind, you know, and you can try to talk to them. I mean, you know, some people are a little more, how should we say, hard to convince than others. Jake, you were one of those in the beginning, but after, you know, a substantial, what was it, 90 days at least, I think, before I got you to actually see where we were going.
You started communication with me in mid-September. You turned me on to the sun. Being, first of all, you got me turned on in the right direction as far as the sun is the problem, first of all. Because everything that I did prior to that had nothing to do with what was really going on. So you were the first to show me that the sun was doing this. And then I started to listen to what you had to say, but again, wasn't completely sold on it myself because at the time, Lee, you know, I didn't know about this. And it was like you were beating this drum all by yourself. So as time went on and the more mini research I started to do and things that I started to see for myself, and then hearing the tone in your voice when we reconnected in January, and then finally, I'd say sometime in April or May, I finally had that eureka moment of it was starting to all come together now. It was starting, and again, this is not something, I'm nowhere near done. I've got so much more to do, to learn. It's not funny, but I'm starting to form a solid grasp of an idea and how to understand this information. And I see it too now. I don't see everything, but I see the main key factors right now. And I know the rest will come the more time I put into this. And and that's what it's been for me since January. Anyway, Mari, do you have any questions? I don't want to bore.
I don't have a whole lot. I answered some in the chat already. If anyone has questions that pop into their heads, please email them to Mari at WTFSky so I can arrange Jake and Lee to answer the question for you. You know, anything, whether it's being sustainable, weather, TSI, send your questions to me and I will make sure that they get answered. It is very difficult to keep up with the chat at times. If your question was missed, please know it was not intentional. We've had people get a little up in arms about us missing things in the chat. Please know it's not a personal thing. It's just we're trying to do many different things at once with this live hangout. And, you know, we always put it on the table, our email, so you can send your question in and nothing gets missed. So Mari at WTFSky.com.
Yeah, and it's like the guy that called in or emailed in today about the bicycle generator.
Right.
Okay. And then, so when I was researching a bicycle generator to email back to you to give you a link that, you know, so we could use it on the show, I found this report where it said that bicycle generators weren't a good choice for generating electricity, and it showed all of these inefficiencies and everything else in this guy's report. Well, I started digging into the guy's report. He's using electronics from the 70s. He's using data from the 70s. He's using inverters and power converters and all kinds of other things to do it, as opposed to the way that it should be done. So of course he was going to have losses of 40% in his design. He even said that there were losses as high as 60%. It's not anywhere near that. And I think that was when in our conversation the other night with Ice Age Farmer, he had actually seen something like that. And that's where he was basing his information from. You know, what I'm recommending is for people to have a 12-volt system, like a 300 or a 400 watt alternator is as big as you need. So something off of like a Honda or a Volkswagen or something of that nature, just something small. Do a belt drive using one of those emergency belts that you can get from Harbor Freight. and just put it right over. And you want the biggest rim and the highest gear that you can get. And you want to put a bunch of batteries in parallel for it. And then don't have a big commercial refrigerator or a regular refrigerator. Get yourself one of those small coolers that you can buy from a truck stop for like $80
Absolutely.
or whatever. It runs off 12 volts. Go straight in. There's no loss. There is no DC to DC converter. There is no AC to DC conversion or inversion. So you don't have any of that stuff. You're just going straight in, simple stuff. You can buy strings of LED lights like the one I've got running right now, lights up the entire back of our barn. It uses, right now, it's at 12 volts and is using 3.207 amps. So that's about 36 watts. And I'm lighting up the entire area to do anything I want off just 36 watts. So if you look at 36 watts there and you say that you can get 300 watts out of the bicycle, that means if you pedal the bicycle or 300 watts or 400 watts out of the bicycle, that means if you pedal it for just 1 hour, you've got 10 hours of lighting off of that, as if you're going to need 10 hours anyway. And that's not even counting if you had a solar panel put into it. So, you just have to think on the lowest amount of conversion possible. Try to base everything on a 12-volt DC system, and then that gives you every alternator out there, any car battery, whatever. And for these applications, when you're buying these batteries, you want to go with big, deep cell batteries or deep cell marine type batteries. So I use like an 8D. It's a Caterpillar type battery, but it's a 8D marine battery, and that works great for these applications, and you just string them in parallel. So it's, there's lots of things that we can do to make it very, very simple and have very low energy draw, like we talked about with the LED lights on the inside of the house. They're charged off the sun. We've got 2 sets that work every single night in a test program that we're doing right now, and they've worked flawlessly. They're blocked by half the day by trees, and they're blocked the other half of the day by cloud cover, and they still shine all night long and have for weeks now. So, and one of the sets has actually been in service for over a month. We just added a second one to it because the first one was so successful. So we're adding another to see what the life expectancy on those are. And that's the other thing with those, when we buy that type of light, we get them so is that the battery that's on the inside is actually a rechargeable AA battery, which means that even if the light doesn't get it and we get like an Energizer or a Duracell battery charger that works off of 12 volts, you can find those in Walmart, and then that'll plug right into your 12-volt bank. And so you got AM/FM radios that are 12 volts. You've got CB radios that are 12 volts. You've got 12-volt light bulbs that you can thread into your house that are maintenance light bulbs. So, my recommendation for everybody is base everything you get on 12 volts and being able to take 12 volts straight in, as opposed to having a 110-volt inverter in line with it, because that 110-volt inverter, if it ever fails, you're done.
Folks, that's why Lee Wheelbarger is here. That kind of information right there, guys. And Lee, I appreciate you taking the time to come out tonight. I think we're going to wrap it up. Again, Lee, thank you so much for coming on to the show.
Anytime, my friend.
All right, guys, you have a good night. We'll talk soon.